Hello, this is Brnya. Welcome to my webinar about functions in JavaScript. And now, as I said, we're going to talk about objects. Let's leave the objects alone for now. Let's talk about functions. So what are functions? Functions are a set of instructions, expressions and declarations we can call using one call. We can execute using one call. We've already, where is it? We've already met some functions. For example, we've seen this. So it obviously does something. So you call functions with what's known as parameters, which is an input to the function, and the function returns something. It does some internal computation on an input and returns some output. Let's try to create our first function. There are several ways how to write a function. This is known as function declaration. So this on its own doesn't do anything. It just declares that those functions exist. We have a keyword function. It's a reserved word in a language. So we declare a function with the name sum or with the name mul, so multiply. This function has two parameters separated by comma, a and b. And again, there's a block. What's gonna happen? In a function you can do pretty much what you can do anywhere in the code. Just a block of instructions, and the return statement exits the function, and actually as a result is gonna be what's here. It has to be here. This is not gonna work. This is just gonna return nothing. We get to the point what it returns. If it returns nothing, it has to be at the same line as the keyword return. So at this point, I accept two numbers, or any values actually, and I return some of those values. At this point, I declare a variable c, and in a c I get the multiplication of those values and return the c. So this is actually sort of the same except for the operation. There can be any expression, anything that holds value. So it can be directly an expression, the expression gets evaluated, or there can be value on its own. It's not considered an operator. So how do we call it? Well, we can call it directly sum and those two parameters 1, 5. So this calls this function. A becomes 1, B becomes 5, and returns the sum of those numbers. We get 6. This is an expression on its own, so I can actually call it like this as well. I can do multiplication, or I can do sum. Let's make it a little bit more visible. That's 7. I can call multiplication. Anything that's after the C after the return is ignored. The function ends with the return call. Whatever is here is ignored. So this allows us to do functionality by a simple call without writing it over and over and over again. What happens if a function returns nothing? It doesn't have the return call, or it just returns nothing. Well, we get the value undefined. That's the special type undefined that has only one value, undefined. That's what happens if a function doesn't have a return statement. It returns undefined on its own. What happens if I miss a parameter? So in this case, B is 5. So the parameter that goes into a function is 5. We have the result. If you omit the parameter, it becomes undefined on its own. Undefined times number is the special number, not a number. So let's say I would have some we already know we can concatenate strings using the plus sign, and the result is hello world. If I skip it, it's hello undefined. You of course cannot skip like the first parameter. There's no way to skip first parameter. You would actually have to pass the value undefined to the function. Let's put it into my sum form. Let's leave it into my multiplication function. Okay. One thing you can notice is that the program jumps. So the program runs, those are, as I've said, declarations, they don't do anything. So the program starts with the output start, then the function is called, so the program jumps into function and starts executing the function. So this is the second thing that's being called, that's being outputted, because it jumps from here to here. Then when the function returns, the function ends, the program jumps back here, or actually here, which means this get evaluated, returns C, which in this case is going to be 6. C is assigned a value of 6, and the program continues with outputting the result. So calling the function actually jumps into a function, it remembers that it's here, executes the function, returns the value, and continues from the function call. This is a basic of functions. As I've said, functions are useful when you want to do something over and over again. Of course, in this case, this is a very simple case. I can just replace it. The result is the same. So let's say we have a math application, and the math application works with radians and degrees. If you know anything about math, there are two ways how to measure angles, in radians and in degrees. In degrees, the full circle equals 360 degrees, or it can be typed as this usually, or full circle equals 2 pi. Imagine here the pi sign. Greek letter pi. And radians. It has to have a measurement, it has to have a value. So full circle is either 360 degrees or 2 pi in radians. Now let's say our math application needs to work with both. We need to be able to convert one and the other. So we can continuously type, okay, so if we need to convert degrees to radians, we can always write our radians equals whatever the value of degree is times pi divided by 180. So every time we would get degrees and needed radians, we would have to write this over and over again and remember it over and over again, input it into every calculation we are doing. Or we can design a function, degrees to radians. It gets one parameter, the number of degrees, and returns the degrees times, let's say, 3.14 divided by 180. So 1 degree is this number of radian. There's actually a constant in JavaScript called math pi. It's actually the pi. So if we convert 180 degrees, it's actually pi. Because full circle is 2 pi, so half of a circle, which is 180 degrees, would be 1 pi. And the same way, we could do that to degrees, so we get radians, and that would be less. So 1 radian is 57.3 degrees. Math pi radians is 180 degrees. This is 180. What I'm doing here is that I have to evaluate it based on the parenthesis precedence. Again, I have outer function, inner function. So first I have to evaluate the inner function. The same as in math. If you would have, I don't know, sinus, cosinus 45 degrees, you would have to evaluate this first and then evaluate this. The same way you evaluate this, which becomes pi. Now you're getting radians to degrees. 1 pi is 180. Those are inversion functions. Of course, when I convert degrees to radians and then the amount of radians back to degrees, I should get the same value. This makes it much more readable than this. It's still the same, but this is much harder to read, much harder to understand what's going on here, because there is a constant, and the constant is everywhere, and it's harder to see that this is actually the value we're working with. Those constants are part of the formula. We're actually working with this value, and if I did something like this, it makes it much harder to see, to understand. We can design another functions. For example, let's say we want to write integers, positive integers, in decimal base, and we want to write it in binary base. So I hope you know what it means. If you don't, small introduction to bases. Well, we work in decimal base. From 0 to 9 we have 10 digits, so it's a decimal base. So what happens when we need more than 10? When we sort of overload. There's no longer enough to have a single digit. We need more. We need to overload. We overload it like this. When we add 1, it becomes 11. When we add 8, it becomes 19. When we add 1, this cannot be increased. We again need to sort of overload. It becomes 20. So it increases more to the right, and the left side, or more to the left, I'm sorry, and the right side starts all over again. So we get to 99. If we add 1, this is not enough, so we start from 1. We increase this. Well, this is not enough. I'm sorry, we start from 0. This is not enough, so we again have to start from 0, and we have to overload. So this is actually how numbers work. And when we want to explain what this is, let's say what this is, what this number means, it actually means 10 plus 5. This number means 2 times 100 plus 7 times 10 plus 8. Also known as 2 times, I cannot write it, I don't have, but it would be like this. 2 times 10 to the power of, let's imagine this is a, well, this is actually a power sign. This is an operator that does power in JavaScript. Where is it? Exponential. So is 8. 2 to the power of 3 is 8. 3 to the power of 2 is 9. So 278 means 2 times 10 to the power of 2 plus 7 times 10 to the power of 1 plus 8 times 10 to the power of 0. Anything to the power of 0 is always 1. It's a basic math. Well, again, 1. Oh, this is how basis works. So what computer doesn't have, that cannot compute in base of 10. It computes in a base of 2. It only has 0 and 1. Something is on and something is off. That's all computer have. So how the number that we know as a 5 looks in a base 2? It would look something like this, or not something like this, exactly this. I can actually type it, I believe it would be this, yeah, 0b. It's 5. Actually, that's a different way how to type numbers. 0b means, hey, this is a binary number and a base 2. It evaluates to 5. There's also a hexadecimal number. It evaluates to 257. There's also an octal. That's O actually. 0 O. Or you have a regular decimal number. Those are special ways how to type numbers, because they all based on a power of 2. So how do we convert 5 to 2, to the base of 2? Well, the same way how we type this, 278. So if we want to, what does this mean? If I divide it by 10, the remainder is going to be 8. And I have 27. If I divide 27 by 10, I get 2, and the remainder is going to be 7. If I divide 2 by 10, I get 0, and the remainder is going to be 2. This is how we can compute the numbers. So let's divide 5 by 2. Well, that's 2. Remainder is 0. I'm sorry, that's 2, remainder is 1. If I divide 2 by 0, if I divide 2 by 2, I get 0, a remainder is, I got lost a little bit, wait a second. It's just 2, 0, 1, just remembering all of it. It's 1, it's of course going to be 2, 4. Oh yeah, it's correct. So we get something like this. 5. Let's assume like integer diff, not just division with the fractions. Equals 2, remainder 1. 2 divided by 2 equals 1. Remainder is 0. 1 divided by 2 equals 0. Remainder is 1. And we stop the computation. And here we get from the reminders 7 would be, this is 101, which looks the same from the both sides. 7 would be 110. 111 actually. Let's do 6, which is 110. And we start when we get the division of 1. So we get the 110. So let's write a function that will convert any integer and any positive integer. We're not going to deal with fractions or negative numbers. Any positive integer from base 10 to base 2. Okay, let's keep this. What would we do with 0? Well, 0 divided by 0, 0 divided by 2 is 0. Remainder is 0. We end the division when we reach 0, and we end up with only one remainder, which is 0. Which means for every number we have to do the division at least once. And we do it until we reach 0. So let's do it like this. We have some sort of result that will contain the result of our computation. It's gonna be string, not a number but a string, and we're gonna work with some remainder. We're gonna do cycle that will run at least once until this number that we're dividing over and over again becomes 0. So until it's not 0, what we're gonna do, we're gonna say remainder is number remainder 2. We need to change the number from this to the division, which means number becomes this, and we need to add the result. So this turns the number num to the number that is divisible by 2 always. If the remainder is 1, the number is odd. When you subtract 1 from an odd number, you get even number, so it's divisible by 2. Let's do the first cycle. 6, so this is the remainder, so this is gonna be 0. 6 minus 0, 6 divided by 2 is gonna be 3, and this is gonna be the remainder, which is 0 plus empty string, which is gonna be 0. While number is not equal to 0, well, we have number 3. So we start again. 3 remainder 2 is 1. 3 minus 1 is 2, divided by 2 is 1, so number becomes 1. We're now here, and we add the remainder from the right before the result. So now the number is 1. This is 1. 1 minus 1 is 0, divided by 0 is 0, and we add the remainder from the left. Number is 0, the cycle ends, we can return the rest. Base 2, number 15 is gonna be 4 ones. It's 4 ones. If I try to type it, 4 ones, it's actually 15. $29. It's 29. So instead of doing this over and over again, we can write a function, pass it a number, and we're good to go. You can generalize it, base x, it's gonna work for the base up until 10. For larger bases, this is not gonna work. So it's not gonna work for base 16 because we don't know how to express with one character a remainder of 11. 27 divided by 16 is 1, and the remainder is 11. But how do you work with 11 as a single character? So we can call, we have the base x, let's say in octal, it's gonna be 35. It's 29. And you can check it out the same way as we work with math, but this is a base 8, which means we get 3 times 8 to the power of 1 plus 5 times 8 to the power of 0. Well, it's 29. $78. 1 times 8 to the power of 2 plus 1 times 8 to the power of 1 plus 6 times 8 to the power of 0, 78. So you compute the powers from 0, 1, 2. So the highest power will be the length of the number minus 1. There are 3 numbers. The highest power is going to be minus 1, which is 2. Actually works. Well, our function works. Since we're talking about bases, there's a base 16. As I've said, it works. The computer can usually stores data in a base 16. Or something called words, and that's way too complicated if you're interested. But base 16 is often used for expressing arbitrary data, in which case it goes like this. Those are basic characters that we know, and those are the 5 more. So there is 16 unique characters that represents number. So this is actually 8. This in decimal base would represent 10, 11, 12, 13, 14. It's 94. Well, this would represent 15. Oh, it's up to F, of course, I forgot. So that's what this is actually. It's 1. It's up to F, I'm very sorry. From 0 to F. 10, 11, 12, 13, 14, 15. I got confused by myself, so this is how you can see data represented in a computer. For example, when I look at Unicode letter A, the 41 is how the letter A is stored in a computer, and the 41 is here in a base 16. You can see that there are numbers like 4E. So 48 is a representation of a capital letter A in a computer in a base 16. It's capital letter A. You can write it using the special writing mechanism we were talking about, and then the hexadecimal representation. 41 actually is 65 converted to decimal. This was a slight distraction. Let's go back to functions. So the function can make things easier, can make computation easier. You do the computation once, you can generalize it as much as you want. We have it in a base 2, we added a parameter, we can work with that parameter, but we have to pass it. This, by the way, in a base 10 would be 78, of course. So now we have to pass the base, but what if I want base 2? What if I don't want to specify? What if I'm working with the base 2 most of the time and I don't want to specify the base 2 over and over and over and over again? Well, there are 2 ways. The old way that works in pretty much every browser, and there's a new way that works with Let's call it new browsers. I'm not even sure if it's gonna work in current version of Edge. Maybe. Okay, there are some it actually does. So in new versions of browsers it works, but it may not work in like older Internet Explorer. Firefox browsers, Chrome browsers, similarly Opera, Vivaldi, they get updated automatically, but the older Internet Explorer, this is actually Edge, so any Internet Explorer probably won't get updated. So how can we do this? How can we make this parameter to become 2 if we don't pass it? By the way, if we pass 0, we would have a problem. The computation would go forever because this would become infinity. You already see a strange thing. It's 3 divided by 0 is infinity. Come on. First thing, the new thing that we can do that supported in new browsers, we just pass the default parameter. So if this isn't passed, or if it's undefined, which it is if it's not passed, make it 2. So this is in base 2. If I pass undefined, well, it's still in base 2. If I pass 3, it would look differently because the parameter is passed. So the default value of the parameter is ignored. The default value of a parameter is applied only if the parameter doesn't exist or is undefined, which is basically the same. We've seen that. The other way to do it is, well, we could ask okay, it still works. If base is undefined, let's set up the base as 2. Or we can do this. This is called guard, or a default. Guard or default. Oh no, 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 this is not called guard, this is called default. Actually, guard would be this. This is called default. How this works? Well, we talked about logical OR. If this evaluates to true, which is any number except for 0, return this. If it doesn't, return the second parameter. So if this is undefined or 2 is 2, well, it still works. And as I've said, it would actually guard us. It would actually default even in this case, because 0 or 2 is 2. This evaluates to false, so we return this value. Those are two ways how to make default parameters. This type of defaulting to value may be a problem. Let's make a simple concat function for strings. So we have text1, text2, and we can do return text1 plus text2. We got hello world. Okay, so when we don't pass this, it becomes hello undefined. We don't like that. Okay, so let's say we want to default to world. Okay, that works. Hello world. If I pass something different, hello A, it seems to be working. If I pass empty string, it becomes hello world, not hello empty string, because empty string evaluates to false, which means we have to return this. If I do it this way, well, it's actually working. I'm passing empty string, the default isn't applied. Default is only applied when I'm passing nothing. So although this will work in pretty much every browser, even the old ones, there are issues with the defaulting. You can type something like if not type of text, if type of text je různý string. Oh, we would probably have to go with undefined here. The default. Okay, what would this do? Let's check out what will this do. Okay, it's hello A, hello empty string, hello world, seems to be working. Let's still hello world. Maybe you want hello world, maybe you want what, hello 5, in which case you would actually have to go with this. The type coercion, as I've explained in one of the previous webinars, can cause certain issues. You really have to know what you're doing, what are the consequences. This doesn't say if the text2 isn't passed to the function, let's set up it to world. It doesn't say that. It say if text2 evaluates to false, if it's a false value, so-called false value, which is false, undefined, null, number 0, empty string. So it may fail, so you really have to know what you are actually doing. But it is a way how to do it. There can be, of course, functions that have no parameters at all. Why not? If you need some functionality to be done, and you come on. Why? Oh, no. It doesn't matter, but you have to call the function, you have to run the function. Get my name on its own, it's actually the function itself. And we're going to talk about functions, expressions, and other things related to functions in a next webinar. So, thanks for watching. Bronya is out.